In this video, I'm going to be doing a quick review of determining the domain of a function. So let's just start with a simple function like f of x is equal to x squared plus 3. And we want to determine the domain of that function. So first of all, let's remember what the domain is. The domain is the set of all inputs. The set of all inputs, all of the allowable inputs. In other words, what values of x can I allow this function to take on? So remember what a function is. A function, very simply, has inputs, which we usually call the x values, and outputs, which are the function values or the y values. And this is the function. And so when we're looking for the domain, that would be the set of all the inputs. The range, which we're not talking about in this video, would be the set of all of the outputs. Well, to determine what the domain of a function is, the easiest way to approach it would be to start from the premise that it would be all real numbers. In other words, we can let x be anything. X can be any number. And the way that we would write that using interval notation would be from negative infinity to positive infinity. And with interval notation, we use these rounded brackets that represent the fact that we do not include whatever these endpoints are, and we cannot include infinity. So in this particular example, what would be the domain of x squared plus 3? It would be negative infinity to positive infinity, unless there is one of two exceptions. And the easiest way to approach finding the domain is to determine if there is one of the exceptions. If there is not one of the exceptions, then it's all real numbers. The first exception to the all real number domain would be if there is division by 0. As an example, let's say we had f of x is equal to 1 over x minus 2. Well, x cannot be equal to 2, because if we let x be equal to 2, we get 1 over 2 minus 2, or 1 over 0. And division by 0 is not allowed in mathematics. So therefore, we need to exclude 2 from the domain. Now, sometimes you can just simply write x cannot be equal to 2, but if you need to use interval notation, the way that we would write that would be paren, negative infinity, comma, 2, paren, union, 2, comma, positive infinity, paren. Okay, let's just do one more example, division by 0. So if we have the function 1 over x squared minus 9, in this particular case, x could not be equal to either negative 3 or positive 3. If x is either one of those values, then we're going to get division by 0. Negative 3 squared would be 9 minus 9 is 0. 3 squared minus 9 is 0. Using interval notation, we would want to write this as negative infinity to negative 3, not including the negative 3, union, negative 3 to positive 3, paren, union, and then 3 to positive infinity. It's a little bit more time consuming to write it this way, but sometimes that's the way we need to write it. So that's one of the exceptions to the all real numbers domain. The second exception, exception number 2, is a negative underneath a radical sign. Not negative under a radical sign. And so something like that would be f of x is equal to the square root of x. Well, in this case, x cannot be less than 0. So it has to be greater than or equal to 0. This would be my domain. X is greater than or equal to 0. Because if X is less than 0, we get a negative under here. Well, what about if we had the function f of x is equal to the square root of x minus 3? In this case, x has to be greater than or equal to 3. Because we can see if x is less than 3, such as 2 minus 3 is a negative. Now, the way that we would write this in interval notation, the first one is x is greater than 0, or greater than or equal to 0. We're going to include 0, so we use a bracket, 0, comma, infinity. X is greater than or equal to 3. We're including the 3, so we would have 3, comma, infinity, paren. So those are the two exceptions. So when determining the domain of a function, we start with the premise that it would be all real numbers, except if you have division by 0 or if you have a negative underneath the radical sign. If you don't have division by 0, if you do not have a negative underneath the radical sign, then we can use every possible value of x. All right, let's just do a couple of real quick exercises here. You can stop the video, see how you're doing. All right, so number 1, let's find the domain of f of x is equal to 3 over x minus 8. And number 2, g of x is equal to the square root of 5 minus x. Okay, in the first one, we can see that x cannot be equal to 8. So in interval notation, we would write from negative infinity to 8 union 8 to infinity. In the second one, because this is 5 minus x rather than x minus 5, the easiest thing to do would be to take this and say that this has to be greater than or equal to 0, or 5 is greater than or equal to x, or x is less than or equal to 5. Aha! Not greater than or equal to, but less than or equal to. If x was greater than 5, such as 6, we would get a negative number under here. So using interval notation, we would say x is less than or equal to 5, so we're going from negative infinity, comma, 5, and bracket. Okay, I hope you found this video helpful.